So we've looked at factoring with common factoring. We've looked at factoring with grouping. Now we're going to take our full out trinomials of the form ax squared plus bx plus c. A, b, and c are just numbers. So we need to find a pair of binomial factors in most cases when we do these. So we use a method of decomposition. We decompose the quadratic down to its base parts. So let's take a look at that. We're going to expand 3x plus 4 times 2x minus 5 here. So when I expand that out, I'm going to use FOIL again. It's going to give me 6x squared and then minus 15x plus 8x minus 20. Simplify that, I get 6x squared minus 7x minus 20. Okay, so I've expanded that out. So I want to take this and be able to break it back down into this version here. So I have my factor here. So if you notice, from this line here to this line here, these two numbers compose this one. So we need to decompose this middle number into these two parts. We need to break it down into component parts. These numbers happen to multiply to 120, which is what 6 and 20 also multiply to. And they also happen to add to -7. So we need to make a pair of numbers that work in this situation to do that. So what we do is we multiply the 6 and 20. 6 and -20. It's negative 120. So we're going to look for two numbers that multiply to this and add to this. So multiply to -120, add to 7. And so you can work through pairs of numbers that multiply to 120. And if you need to, we know that it's going to be 15 and 8, but you could work through 1 and 120, 2 and 60, 3 and 30, or no, 3 and 40, 4 and 30, 5 and what do we got here? 24, 6 and 20, 7 doesn't work, and then 8 and 15. 9 work in there. Nope. So 10 and 12. And then you'd start repeating 12 and 10 and so on. So there's all the actual factors of 120. Which of these pairs will get us -7 when we add them together? Or put negative, we might have to put some negative signs on them. So if we look through here, not going to work at all. Add or subtract, these never going to work. Add or subtract, these never going to work. Not going to work, not going to work, not going to work. 15 and 8, well, if I do 15 minus 8, I get 7. So it's on the right track. So I need -7. So how about -15 plus 8? Those two numbers work. So I'm going to pick that pair of numbers and rewrite the middle. 6x squared plus 8x minus 15x. So I've just rewritten 7x with those, plus 20. Now I'm going to factor by grouping. So I get a common factor of 2x, left with 3x plus 4. Use the negative sign, common factor of 3. I'm left with, 5. Common factor 5. I'm left with 3x minus 4. Plus 4. Factoring out -5. 3x plus 4, 3x plus 4 there. 3x plus 4, 2x minus 5. There's our original. The order, again, might be different if you wrote -15 and +8 in here. You would switch the order around, but you'd have the same pair of binomials. So the general process here is that we're reversing a binomial expansion. And what we do is, 1, common factor if possible. There was no need to common factor here. 2, multiply the first and third coefficients, which we did. 3, find a pair of integers that multiply to the result of step 2, negative 120, and add to the second coefficient, in this case, negative 7. So we found those pairs. Rewrite the middle term as the sum of the values from step 3. So we rewrote negative 7 as the sum of those values, negative 8 plus negative 15, or a negative 8 minus 15. Finally, we factored by grouping. That's the 5 steps to doing these. So let's take a look at a couple examples. X squared minus 5x minus 24. I'm going to multiply the first and last coefficients because there's no common factors. So 1 times negative 24. So I'm going to look for two numbers that multiply to 24, add to negative 5. They have to do both things at the same time. So you can't say, well, 1 and 24 multiply to 24. They don't add to negative 5. So we got to find that pair of numbers. So we have 1 and 24, 2 and 12, 3 and 4, or sorry, 3 and 8. And, well, wait, 3 and 8, get 5. Yeah, 3 and 8 could work. If I do negative 8 plus 3, I would get negative 5. So those two numbers could work. So x squared plus 3x minus 8x minus 24. So I don't have to list all the pairs. Stop once I found one that works. Common factor, x plus 3. Negative in this case. Negative 8. X plus 3. These brackets should end up being the same. Otherwise, you've made a boo-boo. Or it's not factorable. X plus 3 is the common factor now. X minus 8. We've now factored this out. How do you check your answer? Expand that. If you expand that and you get back to the original, it's all good. You will notice a pattern with some of these that don't have a number in front. Okay, they're called simple trinomials. If you recognize that pattern, you're welcome to use the shortcut to get to the answer. Make sure you understand what the pattern is. Let's try another one here. We got a couple x's and y's in here now, so it's mixing it up a little more, but the same process applies. Multiply the first and last coefficients. 2 times 4 is 8. So that's a positive 8. We need two numbers that multiply to 8, add to 9. This is one of the trickier ones for some people. Two numbers that multiply to 8 and add to 9. Well, when they're one apart like this, in many cases, it's going to be 1 in the number itself. 1 and 8. 1 plus 8, positive 1, positive 8. That will get us positive 9. Positive 1 times positive 8 will get us positive 8. So that's the pair of numbers we want. 2x squared plus 1xy plus 8xy plus 4y squared. Factor by grouping. Common factor in the first one is just x. So we're left with 2x plus y. We don't need the 1. Bring the plus sign down. Common factor in the next pair is going to be 4y. We're left with 2x plus y. Brackets are the same. That means we're probably on the right track. 2x plus y. X plus 4y. There we have our equation factored. So every time we're following that same process, common factor if possible, then multiply the first and last coefficients. Find a pair of integers that multiply to the result from step 2 and add to the middle coefficient. Rewrite that middle coefficient with those numbers, as in decompose it, and then we factor by grouping to complete it.